Hello, welcome everyone to day 6, or I should say lecture 6, and we'll be building up on a lecture 5. Just know that day 5, day 6, day 7, day 8, these 4 days will be related a lot with themselves, and at the end of let's say day 7, I will be teaching you a lot more where you can automate almost everything that you are doing right now. So stick towards day 7. And you will not have to write all the codes by yourself. You just have to write one line and you will be able to get everything that you want, irrespective of how big the data set is, and we'll automate everything. Now these are the libraries that we know, but we don't use much in the data science because they're not famous enough. But it's best that you know all these libraries. That will increase your efficiency by a lot. By the time someone will write all the codes, you will be able to get all the work done and submit the report to your boss if you have to. To stick towards J7 because we'll be working with efficiency. I am really excited for this lecture 6 because we'll finally be writing codes on EDA, that is exploratory data analysis, not just doing the theory. Although with day 6 I will also be providing you a let's say a Word doc or let's say a PDF where you can find all the theory of all the topics that we'll be covering as codes. Second thing that you might want to know before we work into this, the next 4 or 5 minimum 4 or 5 days that we are going to have ahead, all of that will have all the codes written already in my Jupyter notebook, right? So stick with me and I want you to write the codes with me and pause the video in between. So let's say I've written the first name of the library, which is already written in a workbook. You will pause the video and then you need to copy the entire function in your Jupyter notebook and perform with me. That's how we both will be able to benefit from this course. So let's dive into it directly. So from theory to paper, that is functions for EDA, the first thing that you might want to see is the libraries that I'm importing. So I'm importing pandas as PD, numpy as NP, seaborn as SNS, matplotlib.pyplot as PLT. Now these two are used for visualizations majorly. Although seaborn is also used for other purposes also. From SciencePy, I want to import only stats library. So under SciencePy we have like a lot of libraries. You can search for SciencePy over the internet. You will be able to get a lot more information about what this library is all about. And we only want stats for now, right? The second thing, after you actually write all the libraries in your Jupyter notebook, I'll pause here for some time. The second thing that you might want to know is that we are going to generate data now, and there is a clear difference between me teaching you without creating the data and just giving you Excel files. It might happen that you are sitting in an interview and the interview will ask you, I want a box plot of this particular function. I want you to give me the box plot. I want you to tell me what the code will look like. Now in that case you will not have the data set and you might have to create by yourself. So sometimes we'll have the data set wherever we know. In practical examples, whenever asked to you, you will always have, let's say, the data set given to you. But sometimes that's not the case, and that's why we are always going to create the data set, right? And for creating the entire data set, we are going to use NumPy. Although creating a data set is like a 2-step process, and we'll work around with that. First we use NumPy and then we come to pandas. So we'll create the data, and I've given the name of the function as data. So the name of the function is data. I'm using NumPy. Under NumPy, I want random values. Okay, I'm using random for that. And I want these random values to be normally distributed, right? And I want the mean to be, around 50. It can be 50 and 52, 49, 48 or 50, around 50. And I want a standard deviation of 10, right? That is the scale to be 10. And the size of the entire data set should be 1000. So I want 1000 data points. Now always remember, while we are creating data set using NumPy, it is unstructured data, and we always need to structure it first in terms of rows and columns, and then only we can calculate the mean, median, mode or exploratory data analysis that we want to, right? So we'll dive into that and how we can do it. Also remember that in random and normal, the first word is not capitalized, but in data frame the first word is capitalized and data D is capital, F frame is capital, and we're going to use pandas. So we write pandas, that is PD, and from the library of pandas we want the data frame function because we want to convey the data that we have created here using NumPy, and we want this data to be in a structured way. That is a data frame, right? The data frame is just like how Excel looks like, And if I'm going to click here on data, and I want the name of the column to be values. Now if I change the name of the column here, all these functions that I've written here already will also be changed accordingly, because I will be calculating the mean, median, mode, whatever function of a particular column and not the entire data set. I can do for entire data set also, but it doesn't make sense for us right now, right? So NumPy, we use random, calculated using normal distribution, and we gave arguments of what should be the mean, standard deviation, and size. And then we use data frame to convert this function into a data frame, and we named our column as values. Now you can see, just have a look at this. You can see for mean, median, mode, range, interquartile range, variance, standard deviation, skewness, kurtosis, only the last argument is changing, right? I'm highlighting and you can see that. So the first argument is data frame and values in a square bracket. That is, we want from the data frame that we created, I want only the values column, right? Now we have only created values column, and that's why we can just not write values and instead just use mean only. But that's not our objective right now. We want to know how we can do it for a particular column in the first place, and that's why we are going to use the notation of values. Although what I suggest when you are actually writing codes, let's say copy this. Now I'll go down, I will do Control V, and as I will do this, I'll just change the last words, right? And then I can have a median. Okay, the spelling is wrong. Median for me, right? And this is one thing that you want to know. Sometimes you have created a single line of code that can be reused in some way. Then just copy it and paste it and wherever you fit. So when I was creating all of these functions, that's what I've done. I wrote for mean, and after that I just changed it here and there. I haven't written it again and again. df values. What might happen is values is the small, let's say, column name right now. It might happen that the column names might be very complex, right? So that you might not be able to write it every single time if you have to do all the EDA. Although I'll be teaching you how you can automate everything and you don't have to do all this grunt work. We will be making it very efficient. But in the first place, you need to understand the foundation, and then only we can move ahead with the automation, right? So we calculate mean using dot mean parenthesis, median, mode, and range is basically the maximum value minus the minimum value. If I have to give you an example, let's say you have 4 friends and your height is 160, your friend is 140, and 2 of your friends are 170 and 180. Now the range is not from 160 to 180. The range in statistical terms is 180 minus 150. 150, 160, 170, 180. The difference between the maximum and the minimum. And that's what we are doing here right now. We are calculating the maximum, that is using max function, and the minimum function, and that's how we get the range. Now interquartile range is important for you to understand in the first place, because mean, median, mode and range is something that you can read and you will be able to understand. But interquartile range is something a little different. So if I have to give you an example, I'll take a very let's say normulated example. You have numbers from 0 to 200. The first quartile will be 25th percentile, that is 1/4 of your data. Now this 1/4 of your data will be the first 50 numbers from 1 to 50, and then the second quartile will be 2/4 of your data, that is half of your data, 2/4, that is from 0 to 100, and then we have 0 to 150, and then we have 0 to 200 likewise. So we are basically, what we are doing right now is splitting the entire data into 4 quartiles, quartile 1, 2, 3 and 4. Now why we actually want to calculate the interquartile range? Because we want to see how the middle values are varying. Do we have a lot of extremes, or how is it? If we have, let's say, a lot of data values in, let's say, the middle ground, then we'll be able to understand, okay, mean is in between these values only. And that's why we calculate interquartile range, to see how the middle values are varying. So when we say quartile 3 minus quartile 1, that would be 150 minus 50, the 100 values in the in middle. There's 50 to 150. We calculate the middle values. So quarter 1 we can do it using quantile, and I'm giving 25%, that is 0.25, and then quantile 75% is 0.75. Right? This is how we calculate these quartiles. Variance is .var, standard deviation is .std. Coefficient of variation formula is standard deviation by per unit of mean, and that we can see that for a particular mean how much standard deviation do we have. And then for skewness we have dot skew, for kurtosis we have dot kurtosis, and for 90th percent, I've changed this actually, I can change it again. 90th percentile will be let's try to calculate using numpy now. Numpy, and then we'll ask for percentile function because we want to calculate the percentile, and we want the column name first, and we want the percentile that we want to calculate. So if you want 80th percentile that I had before this, all you need to do is change this value from 90 to 80 and just write 80 here so that you can also know what value you are calculating, right? And I will change it here also, right? This is how you calculate the 90th percentile. Yep. And then we have Z scores. Now the thing about Z scores is the PDF that I will be giving you, I wanted to go through that PDF one so that you can understand what Z scores is. But just know that Z scores are majorly used to know, let's say decide on something if it is relevant or not. And to calculate the Z score, we actually want to create a new column in the first place. That is, we want to use the stats library now from SciencePy, this library, and we want to calculate the Z score of this column. That's how this argument came into picture. We want to use the first library stats, and then we want to use the function Z score, and we want to do it for the values function, right? The standard scores. And then correlation matrix is let's say nothing but what is the correlation between the two values that we are seeing. So it might happen that on a particular day, humidity is related to rainfall that you have in your area. We will have a very positive correlation. Heat, let's say the temperature that you have on a particular day is related to the sun time in your area, right? So for that to have a correlation, always for anything that has co in it, that in correlation, covariance or whatever it is, just remember we are always going to use two values. And in the same way where we calculated this thing, random values, we will create a second variable which will be named as values 2. So df values 2, numpy, random, normal. Now the mean as it is 55, scale is 15, size remains the same. And to get the correlation matrix, what I will do is I will write a correlation matrix and I will write the name of the data frame .corr. And what will happen if I'll do this? So values 2 is second column and values 1 is the first column. So all the columns will be shown to me, and it will tell me what is the correlation between each other, right? All the columns with each other, what is the correlation? And that's why we need not give any let's say input for what column do we want to have in our correlation. We can just do it. I will write, okay boss, give me df dot correlation, and we'll get it done. Summary statistics is something that we can also get. Now this is something that is easier, very easy for you to do it, and we can just write df dot describe and you will be able to get it. Now there's a special type of printing that we'll be doing, and we'll not write only print give me the mean or whatever it is. We'll actually whatever function that we have created before this, mean, df values, dot mean, parenthesis, whatever functions that we have created before this, will actually print it in a certain way, so that we are creating a function using f, and then we start the quotes. And once we start a quote, we want the text visible as mean, and whatever value that we are getting out of this function, that will be inside these curly brackets. So if I'll go down, I should not though, you can see this number, mean, the dots, and then whatever value do we have here is shown, right? Same goes with median, mode range. But the thing is, you will be able to understand this better once you do it by yourself. But you can see most of the things that I have mentioned here are mentioned in the almost same format, except the last two where we have /n. So if you will see why I have /n in the first place, that is because I want the data set in the next line. So we have colon and the data set, the data point. But for correlation metric, colon is there, but then we have the entire table, right? This is generally done when I want, let's say, a very clear table, right? And that's how we have correlation matrix here. Summary statistics. If you're just doing this thing, that is df.describe, you will get how many data points that you have. We remember that we have, let's say, 1000. We can get mean, standard deviation, minimum, first quartile, second quartile, third quartile, and maximum, right? So this is 0%, 25%, 50%, 75%, and 100%, right? These are basically the percentiles. And mean is here. If you want, let's say, a very generalized EDA done and your objective is to create some other model, let's say prescriptive or predictive model, then df.describe works. But if you are into EDA only specifically, and you want to dynamically create a lot of charts for you, and you don't want to write a lot of codes by yourself, you might want to consider the next lecture that I will be showing you. And the graph that we created can be seen here, normal distribution with z-scores. Yeah, you can see what we really want. Using Seaborn library, that is SNS, I want a histogram. You can see a histogram, because the histogram is just like a bar graph but with no spaces in between. And I want values to be there, and I want KDE to be true. I want a title. I want X label as values, Y label as frequency, AXV line as values, and I want the mean on the X axis, and I want the mean to be with red in color. So that's red here. If I'm changing this to, let's say, blue, and now if I'm running it, it will take some time to run, and now you can see the line actually changed color. So you can go over internet, you can see what all arguments can be taken by Python in the first sprint, then we can move ahead. Line style is this particular form. You can again go over internet, you can see. And label, label is basically this, and we write mean here, right? So this is important for you to understand and create that one line in between for mean. We can also do it for median and mode also, so you can see how they are varying inside the entire model. And I want to see the legend, that is this is the legend that we have, and I want the plot to be shown to me, and that's why I write PLT show. That's the last argument that we give generally. Mostly when you are working with let's say a data, let's say a visualization, you use the function where you give input of what type of graph you want, X label, Y labeled, and title. These are the most common ones, and the show. These are the variables that you will be changing based on what type of data that you want, right? So you can see once I'm going to run it, that is shift and enter. Mean, median, mode, range, IQR, interquartile range, variance, standard deviation, coefficient of variation, skewness, kurtosis, 90th percentile, correlation matrix. You can see values will have, a particular column will have same correlation with the same column. That is, with values will have one correlation. Z-score also will have one correlation. Values 2 will have one correlation with values 2 in the first place. You can see it from this graph. Summary statistics is here in front of you. And that would be it for this lecture. I hope you liked it, and there are like a lot of things for you to consume, and I hope you were able to absorb most of it, and I'll see you in the next lecture. Keep practicing, and after creating random data which is normally distributed, try to not create a normal distribution, and then see how the graph will look like. After that, I would like for you to, let's say, take a data set and then do all of these functions, so that you are well versed with EDA in the first place. After this, we'll actually be working with something as automation, where I will be teaching you how you can skip all of this and just create everything for yourself. That would be it from my end. I'll see you in the next lecture.